Hey, it's Mr. Veve, and this lesson is on population growth. So let's get right into it with our first key concept. Populations grow in predictable patterns. So what we're going to look at here is a couple factors that influence population growth or population decline, and we're going to look at the actual patterns in which they grow in a couple different ways. So first thing you have to know is that population growth is based on available resources. If the resources just aren't there, the population isn't going to grow at all. So four factors that influence population growth right off the bat. You have immigration and birth. These are positive things that increase population. So people or organisms coming into a population or organisms being born into that population. And then you have immigration and death, or emigration and death. Those are the ones where organisms are leaving the population, so they influence the population growth negatively. So first let's examine exponential growth. And it's a rapid population increase due to an abundance of resources. So when there's lots and lots of available resources, looking at this graph here, you will see a completely exponential growth curve like this. So you see a large jump from early on in the population to later. So the curve looks much like that. And we think of things like rabbits, where rabbits will overpopulate an area very quickly, actually. So the other type that we're going to look at is logistic growth. And this is actually a type of growth that will grow very quickly and then face some limited resources and then taper off a little bit. So if you look at this graph right here, this is logistic growth. So you can see over time there is a period of slow growth and then there's an exponential period of growth. And then the population size actually levels off towards the top there till it reaches what's known as the carrying capacity. So carrying capacity is the maximum number of individuals in a population that the environment can support. So normally populations do not go past this carrying capacity because there's simply not enough resources to handle that population. So here's another look at a carrying capacity curve of a logistic growth. So you have a population that has an exponential increase in a very short amount of time, and then it overshoots its carrying capacity. So some of those organisms die off. So you can see that curve going down, but then there are enough resources for it to come back up, and every time it goes over that carrying capacity, it has a little bit of a downturn until it kind of averages out to that carrying capacity, which looks like it's just over 1.5 million of whatever this organism is. So now let's look at some limiting factors for different populations. First, let's look at density-dependent limiting factors, and these are affected by the number of individuals in a given area, so the density of a population. So on the left you have a very, very highly dense population. On the right, a very sparse, so very low density area. So these factors are things like predation. These are much more influential in highly dense populations. Same thing with competition when organisms compete for resources. Parasitism and disease are also much more affect dense populations a lot more than they do less dense populations. So what are some limiting factors that are density independent? Well, these are things that limit a population's growth regardless of its density. And these are things like weather, natural disasters, or any sort of human activities, the things that we do that affect the environment. So there are density dependent and density independent factors. Make sure you know these very well.